Everybody got the bing bong? All right,
Got it.
we are recording. It is January 4th of 2024, the first time I get to say that out loud. This is the SIG Network regular meeting. I don't know how much attendance we'll have today, but let's do it anyway. Um, as usual, we are governed by the Kubernetes and CNCF codes of conduct, which basically boil down to don't be jerks. So please don't be jerks. Not that we have any problem with that. Um, we do have some agenda today, so let's get started with triage and we'll time box it. Let me share a screen. Share. Oh, let me do this in a new window. Share a window. Where is it? Come on. Share a window. Issues. Everybody's got that? Oof, we have 34 opens. Yikes. All right, we'll go from newest to oldest just because that's how GitHub sorts it. Uh, topology aware routing. Unable to allocate minimum required endpoints to each zone without exceeding overload threshold.
Yeah, I mean, I can take a look at this one. I
Hmm.
just taking a look at the spreadsheet. I have a handle
This is the
on
low number.
where it's going. It's a very unfortunate number. I think 11 is a number that just does not work well with the existing heuristic. I'm hopeful that the next heuristic will be better.
Okay.
But
It's on
yeah,
you to respond.
sounds
Thank
good.
you. Kate's cluster issue with access timeout of 1 second. We're preparing to launch ISIO. Maybe they mean Istio?
It's
Or is
probably SEO,
ISIO?
right?
Oh, yeah, right there it says Istio.
Yeah, it's SEO.
When switching traffic. Uh, yikes, there's a lot going on in here. Does anybody want to ask the appropriate questions? Not solve the problem, just poke at it until we get answers.
I'm reading through it right now. There's
Thanks.
Winner.
That'll teach you. Um, E2E tests failed for load balancers. And anybody looked at this? Oh, Antonio, of course, has. Okay, so Antonio's already looked at it. And I'll leave it open. We'll come back to it. Allows support for permanent session affinity. Ah, this one. This came up, yes, just before the calendar. I asked a question here. So this question is, can I have infinite affinity? And I got no real response.
So, kind of related to this, I was making a to-do for the NF tables proxy stuff, and we had talked about, oh, do we want to change the way that affinity works to be different? And there was that whole thing where we deconformanced affinity timeouts anyway. So, if somebody wants to revisit affinity and think about all this stuff, there are a handful of problems.
We also spent some time discussing this in Gateway, obviously, I guess. And I think the overwhelming conclusion we came to, what I guess this was more in the context of timeouts as a whole, but just that it really is as good as yeah, as long as it takes for something to reboot. And so the longer your value is, the less likely it is to be reliable. And I think we found often an upper limit of a week is around the longest many implementations can somewhat safely guarantee. But again, depends on how long it goes until they are rebooted, updated, etc. So permanent feels very hard to.
But even a week, like a lot of the affinity state is stored in kernel memory. So if you reboot, it's gone, right?
Yeah, no, yeah. I mean, any kind of reboot, yeah, it's as persistent as yeah, as a reboot, right? As soon as that's Um, so completely depends on deployment. It feels very difficult to make any kind of guarantee that for any long period of time.
All right. Oh, I pinged Surya. I guess she's not here today.
The other thing is it's also near impossible to have any kind of conformance tests for anything longer than, I guess,
this
I don't know how you
conformance
do
test
that.
runs forever to prove that it never, that they're, yeah, okay. Can't remove node ports from load balancer type service with allocate node balancer node ports false. An LB service has false. Node ports can't be deleted by removing the node port either. Set the node port to be 0. Oh, that's interesting.
I'm sure that this has worked once upon a time. It's a comment from me down the line. Because when we introduced this, I tried actually to remove the node port, and it worked. I even wrote a program which I have attached.
It looks like this might be that patches don't work, but oh well, no.
No, the program doesn't work either nowadays. So something has changed, and it was unfortunately no unit test for it, so I don't know.
I'm going to guess, without looking, I'm going to guess this is some of the work that I did around fixing the service REST stuff so that if you, the idempotency, the request at the time was if I apply the same service YAML twice, I should not get an error trying to change things that I'm not actually changing because I didn't set them in the first place. And so they were 0. And so 0 meant carry the old value forward, which basically turned a replace into a gentle sort of patch, which would certainly mean that in this case, the node ports would go away. How did they come to be in this situation? They had node ports, and then how did the node port get? Go ahead. Sorry.
If you have a service with load balancer type, you will be assigned a node port, so it will actually set the node port number in the spec section.
And they want to unset it.
Yes, to get rid of the node ports.
So they set allocate to false after the fact, and then they want to unallocate it.
Yes.
Okay. That sounds like a bug. It sounds maybe like in that logic where we carry that forward, we could check if the allocate was false, and if it is, then not carry it forward. That seems, go ahead.
Yeah, there are like two patches, one from Antonio and one from the author, a pull request that both works. But Antonio is reluctant to add it because of other things. But I would argue that this has actually worked once upon a time, so we are not like breaking anything.
No, it's probably me who broke. It probably worked before I did all that service refactoring, a year and a half ago, and then I broke it in there. Like I remember writing that code to carry these things forward because of the weird patch semantics here. So I assigned myself this issue, and I'll look at these PRs and see if it makes sense. Okay, next. Flaking test. Anybody looked at it yet? Unclear what the resolution here is. All right, well, it's discussion going right today, so we'll look at it next time. How are we for time? Let's pause here. Unfortunately, we've got some agenda. We can always come back to triage if we need to. Let me pull up the agenda because I didn't do that. Keith, you're up on the agenda. Are you here?
Yep, I'm here. Thanks.
All right. Do you need a screen?
Yes, I do indeed.
Participants. Whoops, where'd you go? There you are. Keith Moore, co-host. Yes, go crazy.
Thank you, thank you. So I feel like Shane put the expectations on when he said this was an important demo. I don't know how important it is, but this was my holiday project. Oh, well, first, for those of you who don't know me, I'm Keith. Work for Microsoft. I'm a Gateway API mesh lead, and I think after Tim's lightning talk at KubeCon, a lot of us who work with Gateway API kind of felt like this glove had been thrown, for lack of a better term, as far as exploring what can be done to make Gateway be a viable alternative to the service resource. A good bit of those, ironically, a good bit of those triage issues were service related. There's a lot of pain there. And so I took it upon myself during the holidays to kind of see what we could do with Gateway in the DNS realm. One of the things that makes services really nice is that you get this really nice DNS name, the SV service name, namespace, SVC cluster local, all that goodness. Most Gateway implementations are kind of backed by service, but the Gateway name does not always match the service name. In Istio's case specifically, in order to deal with conflicts, we actually append the Gateway class to the end of the Gateway name to kind of enforce a level of uniqueness. So, when you want to discover the IP address or even potentially the host names that might exist for your gateway, then you don't really have a great option today. So I went into the Core DNS code base and tried to kind of figure out the question, how hard could it be if you wanted to do kind of some native DNS resolution for gateways? This is very much still a POC, don't have all the corner cases figured out, but I did end up building something that works that I wanted to demo for you. So made a couple of assumptions here that may or may not end up being holding true in the long term, but first assumption is that a given gateway can be in some way designated as cluster local, or to otherwise say that we care about this gateway. For the sake of the demo and what I got so far, there's no diffing. We don't do any designation like that. We just kind of look at a gateway and resolve it as best we can. But I imagine at some point that's going to be a topic of conversation. Number two, assumption that there's going to be some utility that takes ownership of this gateway, and the demo's case it's Istio, and assigns them a virtual IP. And again, we'll want to maybe one day, almost definitely one day, deal with host names here. Three, the cluster IPs are stored in the status addresses field of the gateway resource. And in the case of duplicates, with a service in the gateway with the same name, only it says the gateway IP is returned. I wanted to say only one IP should be returned. And for the sake of this demo, it'll be the gateway. Not what I'm trying to discuss here. We'll get to mirroring in that fourth case in a second. But this is on my fork of the Core DNS repo. Made some bash scripts to be able to build a kind of cluster. And then, once it goes through and builds a kind cluster, it will, I'll walk through the rest of this whole thing. But what I want to do while that is building is take a gentle look at some of the code. So one of the big questions when dealing with anything Gateway API is CRD. CRDs can be there, they cannot be there. So how do we deal with reliability issues of or reliability questions around, what if this resource exists? These resources exist, and if they don't exist, how do we do that gracefully? And so I took a page out of the Istio control planes book. I can scroll and find it with this zoomed in view. But in the Core DNS Kubernetes plugin, I must have passed it. Controller. No, it's not there. What is it? Is it diffing correctly? Oh, it's my master, not the Core DNS master. Well, I'll go to the code this way because I know where it is. So here in plugin, Kubernetes. Controller. Here we go. So let me actually call this out first. We do a read gateway API field in the DNS control. You can see this in the core file, the way this is surfaced. We have a gateway. Whoops, where are you? Yeah, here we go. We have a gateway statement in the Kubernetes plugin. And it gets passed into read gateway API. And if we read the gateway API, we're going to set up the gateway controller. This is just kind of the informer pattern that Core DNS already uses. What we do is when we get the gateway CRD added to Core DNS, that's when we depend on. Eventually, this might also depend on gateway class, but right now it's just a gateway. We're going to store a bool to know whether or not the gateway controller is started. And then we're going to run this a Go routine that actually does the controller bits. And then when the gateway resource is deleted, we're going to close the stop channel to stop the controller, and then store the bool. So this, in my test at least, not claim this is the most robust thing ever, but in my test at least, this responded pretty well to gateway being installed, or gateway and CRDs being added, being removed, etc. I'm going to go over here and check. Okay, we're still building, so we're good to go here. Oh, that's actually the wrong command. So I need to first create the con spec. You do this hack setup. Here. All right, I'll get the con cluster stuff spun up. All right. So yeah, that's how we handle the controller piece of Gateway API. That was the main area of interest that I wanted to cover. Added some sample stuff here. But the rest of the demo is going to be really predicated upon the con cluster being up. So excuse me while I riff a bit. And
Yeah,
go ahead and interject, Rob. People have questions.
Yeah, if we're just waiting for that to spin up, one question I meant to ask earlier, if the gateway does have multiple addresses, do you just pick the first one? How do you decide what you're going to do there?
Yeah, great question. The default isn't great right now. That's one of the corner cases / to-dos. This does not get refreshed. Oh no, I've got it locally. So I've got a to-do locally to kind of investigate how we do kind of fairness or what we want to do when there are multiple addresses. Right now, because they're A records, we just do both. And it'll do the flip-flopping, obviously not super great. I thought about a couple of different options here. Let me see what I wrote in the markdown file here locally. Yeah, we need some way to disambiguate between multiple host names for sure. And if there are multiple IP addresses, then maybe we want to find some way to designate a certain address as the canonical address that gets returned for DNS. The more I dug into this, the more I came to the conclusion that we really probably only want to do DNS with gateways that have a certain shape, or find some way to constrain what the gateways look like, or else you could get those flip-flopping semantics. The example I can think of is if you've got a gateway with a public and a private IP address, you don't necessarily want to flip-flop between the two. So either we need to find a way for the DNS query to specify which one. That seems interesting. Or we need to create some sort of requirement in the spec that there only be one address. So that's kind of what I've got so far when it comes to how to go about doing that. Does that help?
Yeah, no, that makes sense. I'd be really curious, we could theoretically just, I think where this is leading is a request to modify Kubernetes DNS specification to say that this is how you should handle gateways. And I think one of the simplest possible interpretations would be take the very first IP in the list of addresses and resolve to that. And, implementations can strategically populate that as they desire, is one possible interpretation.
Exactly. Yeah. Realized I wasn't sharing my whole screen, so you couldn't even really see my terminal. So apologies for that. You should be able to see the terminal now.
Yeah.
Okay, so the Kine cluster is up. Pretty normal Kine cluster. What we're doing in this other terminal is just building the local version of Core DNS. The Kine cluster spin up just does a couple of things, and you can also see my VS Code. We have to change the cluster role because now our reading gateway needs to give permission to do that. And then we're going to deploy this custom core DNS config map. In this case, like I mentioned before, we're going to just add gateway to the Kubernetes plugin stanza, and then do MetaLB so that we have load balancer services like normal. So we update the core DNS image here. This piece is done. We built the image, updated it. So now we're ready to actually do the fun stuff. So we're going to install, well, first, let me log the core DNS pod. I've got debug logs on, so that's why this is spewing a lot of stuff. It is just a POC. But you can see that we're looking for CRDs, get LML, LB CRDs, and ignore those. And then now we're going to install the Gateway API CRDs. And now, yeah, we got the controller started. We get some errors that the server couldn't find the requested resource. I believe this goes away. I believe this is just an error that the informer got because of a race condition. But I believe this continues to work. We'll see. Now I need a gateway controller. Again, I use Istio because that's what I'm familiar with. But you can really use any gateway controller. And again, you see the core DNS ignoring all these different CRDs. And so, yes, we will install this Istio as the gateway controller. We'll see the namespaces there. The next step, get to the right directory here. Next step will be to install the sample apps into the cluster. So we're going to just apply those here. We've only got, I'll walk through that right quick. We've only got a couple of samples, HTTP bin, lit service account. Well, this first is the sleep pod, and then HTTP bin and lit service account. And then we also create a gateway for the Istio gateway class for that sends traffic to the HTTP bin pod. So, all right, Istio installation is complete and successful. We're going to install, create those pods, wait for them to come up. So the Istio controller has, while these are being created, we see the Istio controller has gone ahead and created a pod for the gateway. It's running Envoy. It's also got the service. We expect to see this external IP return in DNS, but not this cluster IP. We don't want to have to query this cluster IP service either. So we're going to wait. Okay, the pods are up. So now let's look at the gateway, make sure the gateway has been programmed. This demo only returns IP address for programmed gateways. And we see that the IP address has been assigned to that gateway and that it is programmed. So now all we have to do next is run an NS lookup in the sleep pod for the HTTP bin gateway. And notice we're I'm gonna make this a bit bigger so folks can really see it. And so notice here, instead of querying the service schema, we're querying HTTP bin gateway, it's the name of the gateway, dot defaults in the default namespace, and then the gateway schema with cluster local. And we see we get the address of the gateway returned instead of the cluster IP service like you would in a typical DNS lookup. So that's the first piece of the demo. For as an opt-in, something I didn't think a ton about. This obviously would need a lot more discussion and fleshing out. I also created this mirror mode. So what you can do with this same demo is apply a new CoreDNS config and add this mirror piece to it. So what this will do is it will mirror the gateway IP address into the service schema. So let me go ahead and apply this. CoreDNS at some point will catch this automatically. For the sake of time, I'm just going to restart the CoreDNS deployments to pick this up. And so what this will allow us to do is to be able to do a kubectl exec and query the HTTP bin gateway in the service schema and not just the gateway schema. So I'm going to get the new CoreDNS logs. This is a new pod that came up. And now when I run this NS lookup in the service schema, so HTTP bin gateway default service cluster local, now I also get the same IP address of the load balancer and not the cluster IP. So we've mirrored the gateway addresses within the service schema. So like I mentioned, and Rob brought up a couple of good points here. He still has some open questions. Like if this did turn into a part of the CoreDNS spec, you have to figure out some edges around hostname addresses, around CNAMEs, have to figure out what to do about listener host names. So if you've got a host name for a listener on a gateway, like a curl command will have to specify the appropriate host for that IP address for traffic to be accepted. It could lead to some unexpected failures for users who don't add that host name. Maybe this is guidance that we say that we offer to users to say if you want this DNS to succeed, always create a listener for the in-cluster DNS name. Again, maybe we create it as part of the spec where we say you can't have a host name on listeners or something like that. Just wanted to kind of show this to everybody, see where your brains go. And how useful this might be for folks. It was, like I mentioned, a holiday project while my wife was sick with COVID. So yeah, hopefully this was something cool. And yeah, let me know if you have any questions.
Hey, Keith, I want to thank you for pulling this together. I love when people take an idea and run with it and explore and see what works and what doesn't. I have so many questions that go all the way back to like, do we want to share a DNS schema with service, or do we want an alternate DNS schema? We've long hated the existing DNS schema. Like, is this an opportunity to go and reevaluate that and say, yeah, services are the old way and here's the new way? What would that look like for consumers? There's a million questions I have. We don't have time for all of them, but this was a super cool demo. I'll stop blathering, see if anybody else has any other questions. But I know Shane had made some suggestions to me about maybe overloading gateway might not be the right path here. Like he saw my talk also and took the different interpretation, which is the pushback side of things, which I'm also very okay with. But this is a great chance to discuss. I see a hand, Rob.
Yeah, no, I love this. Thank you, Keith, for turning this into reality so we can play with it, see how it works. I think that DNS was, one of the things that made service as successful as it was, right? It just felt like magic, right? So having that for Gateway seems amazing. And I think that it's relevant whether or not we have cluster IP gateways, right? It is just a very useful mechanism to have in a cluster. By very definition, Gateway provides more advanced routing than service. And so I can imagine many people will want to be able to access a gateway from within a cluster, whether or not it's a cluster IP or not. It just seems like a useful mechanism to have standardized.
The big problem with DNS, and the thing that we ignored at the beginning is TLS, right? And like it just auto-assigned DNS and TLS are sort of mutually incompatible. And as TLS becomes more of an like everybody has it even on the back ends thing,
yeah,
it becomes more difficult to be useful. DNS works great for these L4 things. It's much harder with the L7 thing.
Yeah, that's very good
Unless
point.
we also start issuing certificates.
Well, I mean, yes. 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 That's a fun one. Yeah, so very, very good point. Worth digging into. I'm really curious what the appetite for, if we can get these things figured out, I'm curious what the appetite for a change to Kubernetes DNS spec is. Even, like, let's say that we solve that, we have some kind of solution for TLS, because like you said, that is pretty important at L7, which is vast majority of gateway today. I don't even know how we even started. It seems like it's been forever since any portion of DNS spec has changed in any meaningful way.
That's true.
But
I have a doc that I wrote it several years ago. It was one of these Christmas docs where I would come into the office while nobody was there and like try to get all the things that have been banging around my head written down, and then I never really followed up on it. But I started to think through how we could possibly evolve a second DNS schema that fixed many of the problems with the first schema, especially the dot expansion stuff, which continues to be a pain in the butt to this day. And fix some of the sort of hierarchical nature, fix the embedding of the word service into the schema, and possibly even fix the lack of pod DNS, which continues to sort of be a thing that people stumble over, especially newcomers. And with the growth of sort of batchy workloads, having some sort of DNS for pods also becomes important, and people are using headless services as a way around this. I've seen a disturbing pattern of people creating a headless service that selects all of the pods in their namespace for every namespace, and just using that in order to get DNS names for pods. And for these batch workloads, they may have thousands and thousands of pods, and then they have a DNS name which you're supposed to query, which gives you back thousands and thousands of A records, which doesn't work, as Antonio has stumbled over. The Go DNS resolver is broken in this regard. There's actually like violating RFC, or the RFC is ambiguous. So it's sort of a rabbit hole. But this is an area where it's not a like burning fire, but it's definitely been smoking for a very long time. Awesome demo. Anybody else have any questions? Okay, Keith, what do you want to do with this next? Like, do you want to try to turn this into a cap or a pre-cap in a doc of like, now that we've proven that the idea, is at least not impossible, how do we want to go about it? There's a lot of assumptions that you've made through here that I think we should talk about. Or do you want to let it sit for a while? Like, what's your plan?
Yeah, so my plan at this point is to continue to kind of let this percolate. I'm planning to demo this Net Gateway API meeting, talking to folks internally, just let as many people as I can see it. Because like you said, I think that the attitude towards DNS at this point is that it's maybe smoking, but it's not dramatically broken. And people are using it, so it's not paying a lot of it. It's not really a place I see a ton of people paying attention. So I just want to kind of let people have, pay some more attention to it. I'm by no means a DNS expert. I learned a lot of things in just going through this demo. So would love for people with a lot more history with DNS and Kubernetes than I do, a lot more expertise in this area, to kind of give their thoughts. I'm very interested in some of the millions of questions that you might have, Tim, and just to kind of see what the right direction for this would be. I see a lot of potential for it to be maybe a catalyst to fix some other things, a catalyst towards something akin to a cluster IP gateway. Like there are obviously other questions there that doesn't solve IPAM. It doesn't solve like any kind of default implementation. There are lots more questions there. But with one piece of the cluster IP gateway thing, I won't say even completely proved out, but at least experimented with. I'm hoping that more people kind of combine their thoughts, and out of the primordial soup that comes out of that, maybe something will emerge that is workable.
All right. Well, and Shane, I don't know if Shane's still here. I know we talked recently about, whether Gateway was the right vehicle for this or not. This is the place where I'd love to hear the refutation and have the discussion about whether the UX of Gateway justifies or rather the benefits of Gateway justify the UX of it for this use case. I know this is something I've heard other people say too. So I think this is a good conversation starter. Thank you for that. I'm going to push on to the agenda. We have next Rob talking about reference grant.
Yeah, this is a simple one. In the spirit of having some time over the holidays, I had some time to build out a POC. This is only what I would say tangentially related to SIG Network, in that reference grant kind of originated here and could be potentially useful for other SIG Network APIs. But as we've got an interest from other SIGs, including SIG storage, it has been clear that it needs to move upstream to Kubernetes. SIGAuth was the winner of that lottery, whatever, for where it would land. And they had some, as you would expect, some strong requirements on what it would take to get it into tree. And this specific POC imagines what would happen if reference grant not only granted access that controllers implemented, but it actually granted access to the controller themselves. So a gateway controller might only have access to the secrets that were referenced by a gateway, for example, instead of all secrets in a cluster. So expanding the problem a little bit to try to solve the painful problem of something exposed on the edge that has read access to all secrets in the cluster. Yeah, at a rough level, it appears to work. But some feedback and any kind of assistance, if this is an area that interests you, this is the cycle we're trying to get it into alpha, which means 1.30 is coming up. We've got around a month until KEP freeze, wildly enough. Yeah, just a heads up that this is happening, and if it's an area that interests you, we will be working over the next few weeks to get the KEP in and hopefully some kind of implementation. And yeah, that's it.
I'm very interested, but I'm not gonna really have the time to digest the KEP properly. So maybe we can catch up sometime, and or maybe come back to one of these meetings with a not a demo, but like the recap of where we're going with it in a little bit more detail.
Yeah, for sure. Yeah.
Awesome. Okay. Last on the agenda, Seth wants to talk about an issue that is opened and looks like it was closed. But Seth, the floor is yours. Are you here?
Yep, I'm here. Thank you. Yeah, this is one that I opened a few years ago. It's a little bit of an extra one. So we have kind of a legacy workload that uses underscores in DNS names. And so for that to work in Kubernetes, what we would like to do is to set the search string, to the name that contains that underscore. That doesn't currently work. We found a workaround at the time, which is kind of why the issue got dropped. But I wanted to re-raise this and see if it was still possible to kind of reopen this.
And you specifically want to put this in search strings, right? Not in
Search strings only. Yeah.
Yeah, not in a pod name or a service name or something like that.
No, I don't want to relax anything except for the search string specifically.
I'm quickly scanning the issue.
So I just added a comment a few minutes ago.
Okay.
At the very bottom. I mean, it is invalid, I'm pretty sure, to have underscores in a host name. So, while we could loosen the restriction to make this work, for everybody else, it would just mean that we would be allowing, one more invalid string that would be guaranteed to not work for them, presumably. To the extent that we're validating it all, we want to stop users from putting in things that aren't going to work. And
so I'm going to have to click through and read the citations because I read another one of the RFCs that superseded 1123, and my interpretation of it was basically a DNS name is anything except nil or a dot.
Right, a DNS name. But that's because DNS can contain more than internet host names. And host names are still restricted to the same syntax they always were.
Okay,
for instance, serve records can contain underscores.
Sure.
But
so Dan, in this case though, I mean the search string is not a DNS host name.
Yeah, I mean it's ambiguous. I mean,
yeah, I agree, and that's why I prefaced it too by the only reason we're kind of looking into this is because we have a legacy workload that uses the names. Like we wouldn't choose to name them this way.
Yeah, I mean, I think the reality is that a lot of things do support underscores, even if the spec doesn't require it. I've certainly seen it in things. It's been surprising. Every time I stumble across a host name with an underscore in it, it makes me scratch my head. I'll have to click through and read those citations. I'm aware of what Dan's saying. I want to be really careful that we don't set people up with traps. That said, putting it in search strings seems like the least dangerous place that we can push it.
Yeah, I mean, it would definitely be worse if we were allowing people. Well, but that means that we'll need to split the validation functions because anything where we're creating a host name, we still want to be stricter.
That's right. We would need a different validation, which isn't awesome, but isn't the worst thing. We need to figure out. We need to do the usual ratcheting thing where we roll out a release that supports it in existing data but not in new data, and then roll out a next release that would support it in new data so that you could roll back and not invalidate. Because the worst thing we could do is let people put it in and then have them roll back a cluster and then their existing objects can't validate. All right, I'll click through. Should we reopen this issue? Yeah, let's go ahead and reopen it. I'll click through those and see what I can figure out. Oh, it's already assigned to me. How about that? I think my comment earlier on was still true. I don't really object to this for search because it's a totally opt-in thing. I do want to think about if there are any ramifications that we need for this. It's not going to affect core DNS because it's not serving those, right? We're not going to allow underscores in a cluster suffix, so you can't name your cluster, something underscore something dot local. Okay, we'll look at it and hunt through it. Now is the time. Do we need to KEP for this, probably, because it's going to need a gate.
Yeah, and I can draft a cap if you feel one is needed.
Yeah, probably. It doesn't need to be a very big one, but this would work through the, it's not going to affect core DNS. It's not going to change service names. It's not going to change pod names. It's only for search paths. And here's the name of the gate, and here's the life cycle over the next 2 releases. You can start in alpha and go straight to GA in 30 and 31 probably. And then we can discuss if there's anything that we're missing in there.
Okay. Would you like me to draft a cap for the next occurrence of this meeting?
You've got, that's up to you. We don't need to review it at the meeting because it'll be a relatively small KEP. But if you write a KEP, open an issue, and then you can just send it to the mailing list and say, hey, I've got the KEP for this issue. It's very, very short. It just answers all of the readiness review questions and describes the gate. And that's pretty much all you need, I think.
Okay.
Honestly, there should be a lightweight KEP template that covers things like this, but there isn't yet. So, and then we'll see if anybody wants to object after they had a little bit more time to digest.
Okay, sounds good. Thank you.
Okay. Thanks for following up. Anybody else have topics they want to cover today? We got a couple minutes left. Nobody. All right. I will. Shane unmuted. What do you got, Shane?
Cheers. Happy New Year.
Happy New Year, everybody. I'm going to go stop the recording.